So today I'll be kind of going through kinematics and some vectors, which is a new unit. Yeah, I've been really busy for these past months, but I'm back. So for the first, let's talk about vectors and what they are. So what vectors are is just kind of like there's a difference between a scalar quantity and a vector quantity. So scalar versus vector. So the main difference is that scalar doesn't have direction. Well, vector does. So for example, let's say just give me an example. Weight is a vector. Well, because weight is a vector because weight has a direction. And you'd be wondering why weight is a vector, because why it's just like how much you weigh, right? Well, weight is a vector because it has a magnitude and a direction. So for example, mass is a scalar and weight is a vector. So for example, you would weigh different on Mars or like Jupiter than you would on Earth, because what that means, it has a direction because you weigh actually different. Mass is like kind of objective, so it's no matter where you are in the universe, it's still the same mass. But like the weight is dependent on where you are, so that's why it has a direction, meaning as a vector. So yeah, that's what it is. And it's also go through some basic vector, so vector addition. Vector addition is really simple. You should just like learn this tip called tail to tip. That's the main thing about vector addition. So for example, you have a vector A. If you want to multiply by a vector, the tail here has to be attached to a tip. Actually, people also call this tip, but I'll call it tail. I don't know. Wait, sorry, I'm mixing it up. This is tail. This is tip. That should be it. Yep. So yeah, same thing. Tail to tip. So the tail here has to be attached to a tip to multiply. It's for addition. So let's say this is vector B. So then vector A plus B would be this. So this is the resultant vector A plus B. That's vector addition. Well, vector subtraction is a little more complicated, but it's still really easy. So for example, you have a vector A and you want to minus it by, let's say, a B. So B would be like, I guess, just say it's here. Well, how would you minus that? You won't do it like the traditional way. Like if it's the normal conventional way, it would just be A minus B. But for vectors, you don't do that. Vectors, you want to plus, like it's this. It's A plus negative B. So you probably be like a little confused. What do you mean by negative B? Negative B is basically B flipped. So that. Yeah. So this would literally just be vector A plus negative B, which then will be the opposite way, go like this. And then, the resultant vector, dot tail to tip, boom, tail to tip, A minus B. This is the resultant vector. So yeah, that's pretty simple. Now vector addition is more a little complicated. So for example, I'm mixing it up. Vector multiplication, okay, yeah. So for my vector multiplication, there's this thing called the vector cross product that we won't be learning, but we'll be learning the vector dot product. The vector dot product is basically how we do multiplication. So first of all, it's just this: A times B, vector A times vector B equals to the magnitude of A, magnitude of B, times cosine to the theta. So essentially it's literally just, for example, if you don't have an angle, that means the angle will be 0, and cos 0 just equals to 1. So I'm pretty sure cos 0 cosine 0 equals to 1. So let's say 2 times vector 2 sorry, 2 times 3. Bueno, sorry, that's a really bad example. Vectors have 2, so like 2 and then 2, this would be vector A times 3, 2, which is vector B. So in order to do this, you would do this. 2 times 3, and you would plus it to 2 times 2. So 6 plus 2 times 2 is 4. 10. So this vector will give you 2. Will give you 10. And yeah, if you want to find an angle between them, this is the formula. It's basically reversed by the original formula. It's like this: magnitude of A, magnitude of B. So yeah, this is the formula if you want to find some angles. So I don't really have a good example for this, but just kind of a formula. And yeah, so now I'll move on. I'll move on to more difficult, and this is what we're like primarily focusing on: kinematics. This is a alright question, I would say, and this probably would be on a test. So yeah, 2 planes A and B are flying at constant velocities at 6 a.m. So it's constant velocities, that's key. Plane A is at the point with position, so this is the initial position. And yeah, because there's this at 6 a.m. that's the initial position, and then plane B is at this position. For 3 hours later, this will be not the initial. So, and then the one's at this and one travels with velocity this. So first of all, the question tells us to find the velocity of A in terms of I and J. So I don't really like writing I and J, like I'll say it's really confusing. So I like to do it in component form and then at last convert it to I and J. Because I don't think they would ask you, because this is a ChatGPT generated question, so I'm pretty sure the teacher won't ask you to just specifically write it in I and J, because that's what we did in class. We had to do component form for most of it, and I and J was basically like mentioned twice or once, so I don't think it's that important to do it in the form. So first of all, this is the formula. So initial, so AB, this is your initial position, plus your T time velocity, this is your velocity. It's not the same, so wait, I should probably use different letters, D and E. This is your velocity vector, and equals to your final position. So that's the formula. That's pretty conventional. It's pretty primarily used in every single kinematics equation, but let's start. So find A. Where does A start? A is at the point position 10i. I just means to the right. I just means like x, and then 15 means 15. J just means y. So 10, 15 plus t. Do we have t? Sorry. Yeah, we do have t. 3 hours later. Plane. So this is for plane A. So I should probably mark that down. Plane A. And then yeah, plane A at 3 hours later. But we don't know the velocity. They never gave us a velocity vector. This would be AB. Equals to 22:45. This is how. So this is a pretty easy problem to solve. You just gotta use algebra, and let's do it. So 10, 15 plus 3a, 3b. I'm just using this to represent the unknown vector. The unknown velocity vector equals to 22 45. 10 plus 3a equals to 22. 15 plus 3b equals to 45. That's how you, like, it's literally really simple algebra. But yeah, you can see 15 plus 3b equals to 45. The x equals to x, y equals to y. So let's do it. The equation, just 3a equals to 12, and then a equals to 3 times 4 is 12, so a is 4. And here 15, what the sorry, yeah, right there, 45 minus 15, that's 30, so 3b equals to 30, b equals to 10. So the velocity vector for plane A is 30, 4 and 10, right there. Right, kilometers per, yeah, it's kilometers per an hour. Now, yeah, if you want to convert this, you should just, like, this would be 4i plus 10j. That should be it for the first part. And the second part, find expressions for a and b. So okay, it's basically asking me to find expressions. Well, first let's just do a's because we already have a. For expressions, don't write t, because t is what are, like, we're inputting. So plus t, 4 and 10, because that's what we got here. So you just plug this in, equals to, you don't have to write equals because that's dependent on t. So that's the first equation for plane A. Plane B, pretty easy too. So plane B, same as that, 5i minus 8j, 5 negative a. And then 3 hours later, travels they literally give it to you, velocity. So plus, what is it, 4 and 6. So that's the two equations, and they told us to write it in terms of I. Yeah, so sorry for the t here. Well, you can just do 10i plus 15j plus, kind of like that, plus 4t plus 10t, that equals to 5i minus 8. So wait, why am I writing in component? Wait, sorry. 5i minus 8j plus 4t plus 6t. Boom.